once again. So let us go for the energy here. This is from the second part of the chapter work, energy and power. Now, I guess many of you are quite familiar with this particular word, that is energy. In your lower standard, you might have learned about different kind of energies there, like wind energy, hydropower energy, and there are many different kind of energies, right? But today we are going to maybe we are going to learn, maybe we are going to bring like two different kind of like new kind of energies in your syllabus here, right? Okay, so let's talk about it, right? Okay, so what do you see in that particular case, that's case number A here. Case number A is that this is a truck which is moving at very high speed, and this particular car which is not moving, and this particular car is at stationary position there. Now, as you can see from this particular picture here, what can we expect from this particular picture is that this particular truck is going to collide with this car here, and this car is going to move to some other distance there. Understand? So what do we see is that a moving object, that means this is an object here, right? Moving object. Okay, so what I'm trying to say from this particular point is that a truck which is in motion and which is coming at a very high speed, it is going to go and it is going to hit that particular car which is not moving, and it is going to drag this particular car to a certain distance. To do this kind of work, we need energy. Understand? So through this particular conclusion here, what we can confirm is that a moving object has some amount of energy. For example, if a student is sleeping in the class, if I throw this chalk on his hand, this particular chalk is moving and it can cause pain to his hand. These particular kind of like work, this particular kind of incidents need energy, so which is why we can confirm that object which is moving can have energy. Understand? Now the second point here, this is a nail. This is a wooden plank, and on top of this there is a hammer. Let's see how. I'm really sorry about my poor drawing of the hammer here. Understand? Now, this particular hammer is at a certain position, is at a certain height. Understand? So this particular hammer is at a certain height, as you can see. Now, if this particular object, that is a hammer, if it falls down on this particular hammer, it is going to go down. This is something we knew. Is that high? Go down. It can cause some amount of work. So from this particular conclusion, okay, so there are two different kind of situations which I brought here. The situation number one, that is object which is in motion can cause a certain kind of work, which to do this kind of work they need energy. Now in the second case, object at a certain height, that means an object which is raised to a certain height can also do some amount of work and they need energy. So in short, how do we define energy? Energy. Normally we define energy as capability. That means ability of doing work. Ability of doing work. Understand? Because to do some amount of work, you need energy for that, right? So this is what we used to call as capability of doing work, energy, right? Now, as I had defined over here, that means the situation number A here, I'm going to bring this off here. This particular trough is going to ramp up. Okay, this particular truck is going to collide with this car and it is going to throw to a certain amount of distance there. Now, can we confirm over here that this particular moving object is having some sort of energy? Yes, because in the absence of that energy, it won't be able to cause any kind of destruction to this car. For example, if I am running and all of a sudden I collide with a person, that person who is at a stationary position, he is going to fall down. Now, why he is falling down? Because I am exerting some amount of energy on that particular person there. Understand? For example, this person is running. Suddenly he collided with this person who is standing over here. Naturally, this person is going to fall down. Why this happens? Because this person is applying some sort of energy. So in short, what we can conclude is that object which is moving can have some kind of energy, and that energy is what we used to call as the energy number one, that is called as kinetic energy here. Okay, this is what we used to call as kinetic energy. Kinetic energy. Okay. In short, how do we define kinetic energy? It is the energy present in a body in motion. Or else you can also write energy possessed by a body in motion, right? Understand? Energy present in a body in motion. Now let us proceed. Okay, so now I'm going to bring another kind of situation here. Now he is pushing this table. Understand? He is pushing this table. As we have discussed in the case of work done, that in that case, work is there, displacement is there. So naturally, this is a work done. But this is also an example of kinetic energy here, right? This kinetic energy, hence this body is in motion there. Understand? So whenever, for example, in this case here, this particular truck is moving at a very high speed. So this particular high speed object is having kinetic energy, but also it is doing some work because it is applying force and it is covering some distance. So this is how we can confirm that kinetic energy is equal to work done. Understand? Kinetic energy is equal to work done. Is that clear? Because any object which is in motion, it also does some amount of work done. Understand? Yes. So, but we knew that work done is always equal to force into distance. We knew that. Displacement. Force into displacement. And according to Newton's second law of motion, we knew that force is equal to mass into acceleration. So we write okay. Understand? So now instead of writing this particular F, can I write MA in place of F? I can also do the same thing here. So I'm going to write this as equation number 1. So what I will write here, substitute F is equal to M into A in equation number 1. Okay? Okay, so now we got something like this here, right? I'm going to copy down this equation once again. W is equal to F into S. But instead of writing F, I'm going to write M into A. That is equal to M into A into S. That is equal to W. This is equation number 2. Is that clear? Okay. Now this is really nice here. But according to the third equation of motion, we got this equation here. This is in the case of motion chapter. We have learned and we have derived through the graphical method. Now I'm going to send this to A down here. That means V square minus U square divided by 2A is equal to S. Understand? So now instead of writing this particular S, can I write V square minus U square is equal to 2A? Can I substitute this value of S is equal to V square minus U square in that? I can do that, right? So I'm going to write substituting V square minus U square to A is equal to S in second equation here. Okay, I'm going to write here second equation. Understand? Now this is becoming very easy here. W is equal to M into A into S. So instead of writing this particular S here, I'm going to write this value here. So M into A into V square minus U square divided by 2A here. Okay? But this particular A and this particular A we are going to cancel it somehow. Understand? Okay. Okay, now what we got is that W is equal to M into A and A we cancelled. What we got? V square minus U square divided by 2. Understand? Now this particular person, looking at this particular example here, that is, this person is pushing this particular table. We knew that before he starts pushing it, he himself, or before me, for example, I was walking. Before I start walking, my initial velocity, that is my value of U, is 0 because I am at rest. For example, we have V square minus U square. V square is the final velocity and U square is the initial velocity. So before I start walking, my initial velocity is 0. Understand? So which is why instead of writing this U0, I can also write 0. Is that clear? So I will get M V square divided by 2 because this doesn't have any kind of value in that. Is that clear? So this I can also write as W is equal to half M V square. Understand? Now this is becoming very easy here. And over here, what we have written, any kind of object which is in motion always does some amount of work. So which is why we got this value here. That is W is equal to half mv square. Half mv square. Now this W is also equal to energy. So I can also write kinetic energy is also equal to half mv square. This is the formula of kinetic energy. Is that clear? Okay, so normally when we were expressing any kind of units in the case of energy, we always use the unit joule in that. Again, we are using the energy joule. Clear? Okay. Okay, now talking about the second point, that there is a nail and there is a hammer which is raised to a certain height. Understand? So, in that case, there is another different kind of energy. Whenever an object is raised to a certain height, we have another different kind of energy, that is what we used to call as potential energy. Understand? Potential energy. The word itself, potential. Potential means you have the potential to do well. You have the ability to do well. We use this kind of sentence in our daily life. Understand? So this particular hammer, when it is raised to a certain kind of height, we use this kind of word here, that is potential energy. Right? Now, in order to understand potential energy, there are three important things which you need to understand. A. B. C. Okay. Whenever we are considering anything about the potential energy, we should always understand that potential energy is always hidden. That is, can you see where is the energy in that? In the hammer? In the nail? You won't be able to see. Can we confirm that there is a presence of energy which is stored in that? Yes, because energy is stored inside this hammer. And is it ready to act? Yes, of course. When you throw this down, it is definitely going to act. Understand? So, for potential energy, to consider potential energy, it is important for us to consider these 3 points here. That it is hidden, it is stored, and it is always ready to act. Now, this potential energy can be classified into 2 parts here. Number 1, I'm going to write here A. Gravitational potential energy. Okay. Now this is in the case of object raised to a certain kind of height here. Understand? This is the height. Understand? And it is also having some amount of mass here. Understand? So whenever we are considering anything about gravitational potential energy, we should always use another kind of formula, that is called as mass into gravity into height here. Okay? Because in that particular stone here, the stone which is on top here, can we see the energy in this particular stone? We won't be able to see because it is hidden. But can we say that there is a presence of energy in this particular stone? Yes, because the energy is stored. The moment it moves down, is it ready to act? Yes, of course, it is ready to act. So potential energy in general means the energy possessed in a body due to its position and shape. This is how we define potential energy. I repeat once again, how we define potential energy. Potential energy are those energy which are present in a body due to its position and shape. Now this is regarding the position, okay? Mass, this is the mass, this is the height, and the gravity is the acceleration due to gravity, whose value is always constant, that is 9.8 meters per second square. Okay? Now the second one here, that is B, elastic potential energy here. Elastic potential energy. The word elastic itself. Elastic. Right? Okay, let's take the example of bow and arrow. Okay. Is it elastic in the string? Yes, it is elastic. Is it hidden? Yes. Is it stored? The energy is stored in that? Yes. The moment we are going to release that, is it ready to act? Yes. So this is a very good example of elastic potential energy. In that, how we define are the potential energy which are present in a body due to its shape, due to its position, due to its shape. This is how we define elastic potential energy and gravitational potential energy. And again, we use the unit joule in the case of potential energy. So this is about the potential energy and the kinetic energy. So thank you very much all of you for listening so well. Thank you.